Let us solve this differential equation. We need to find out what method we're going to use, right? You need to look at the form of this differential equation in order to determine what method we're going to use. Can we solve it by direct integration? No. Right, it's a bit more complicated by just those that we can solve by direct integration. Can we solve it by separating the variables? It doesn't seem so. Oh, hold on. Let's see something here. Suppose you divide both sides by tan x. What would you get? On this side, it would be the y by dx plus y divided by tan x is equal to sine x divided by tan x. Okay. So, what we really have here is of the form p, is one of the form dy by dx plus py equals q. It takes that form. So if it takes that form, we're going to have to solve it by using the integrating factor. In order to solve it by using the integrating factor, the integrating factor in this case would be e to the integral of p dx. But what is p? We need to identify p. P times y. Oh, p is 1 over tan x. It's 1 over tan x. Alright. So the integrating factor is e to the integral of 1 over tan x dx. So let's write that. What we have is dy by dx plus let me put some space here, plus y over tan x is equal to sine x over tan x. But we multiply both sides by the integrating factor. So here we have e to the integral of, oh, I need more space, e to the integral of 1 over tan x dx. This is e to the integral of 1 over tan x dx. And this now is equal to, more space needed here again, e to the integral of 1 over tan x dx. Alright, I'm squeezing for space here, so I have to be writing it small, but let's correct that. Now, here, this 1 over tan x dx, what is it? Let's work it out. 1 over tan x. What is 1 over tan x? Oh, guess what? Remember, the trig identity, tan x is sine x over cos x. Alright. So 1 divided by tan x would be cos x over sine x. So 1 over tan x would be that. Okay, good. Remember our trig identity. So, therefore, what we can say is that 1 divided by tan x is equal to cos x divided by sine x. Alright, so what we have is e to the integral of cos x divided by sine x times dy by dx plus then e to the integral of cos x divided by sine x, or I should have the dx here to show what the variable is, times y divided by, times y divided by tan x. Alright, let's keep it as tan x for now. So let's rewrite that. So times y divided by tan x is equal to e to the integral of cos x over sine x dx times sine x divided by tan x. Okay, good. Now, let's work this out. The question is, what is the integral of cos x divided by sine x dx? We need to work that out. We have to use substitution. Alright? I know it might be tempting to use u or substitution variable u as cos x. If you do that, what would happen is that you'll have u is equal to cos x, so du by dx would be sine x, and then you would say that dx is equal to du over sine x. When you write this, what you would have is the integral of u over sine x dx, but dx is du divided by sine x. So you'd have du over sine x. You still have yourself in a problem, because what you'd have is the integral of u divided by sine square x du. You'd have to go back and say, alright, let's use sine x as our u. So let's do that. Let u be equal to sine x. Therefore, du by dx is equal to, and when you differentiate sine, you get cos. When you differentiate cos, you get negative sine. So if you integrate negative sine, you get positive cos. Therefore, if you integrate positive sine, you get negative cos. So it's negative cos x. So that dx, which we have here, dx, is equal to du over negative cos x. So when you substitute them, you have the integral of cos x divided by sine x, which is u, times dx, which is du divided by negative cos x. So now you have a cancellation. Cos cancel cos. So what you have is negative integral of 1 over u du, which is a negative ln u plus c. Alright? But what was u again? U was sine x. So what you have is a negative sine x ln u, ln sine x plus c, ln of sine x, negative ln of sine x plus c. Alright, so you have that. Now the thing is, let's see now. This is the integral e to the integral of cos x divided by sin x dx. It becomes e to the power of negative ln sin x. We're going to leave out the c when we deal with this one. So it's e to the integral of negative ln sin x. Hold on, did I make a mistake up here? We said when you differentiate sine, oh, it's positive cos, it should be, you know. When you differentiate sine, I get cos. So I need to erase this negative. I did not look back at the table of derivatives. I was trying to memorize it. I know that when you differentiate sine, you get cos. When you differentiate cos, you get sine. Negative minus sine. When you but we're differentiating sine here. Sine give you cos. Alright, so it's really positive, not negative. So it's a positive ln u, which is positive ln sin x plus c. Right. Alright, so we corrected that. So it's e to the power of ln sin x plus c that we have there. So what we have now is e to the ln sin x plus c. Let's write it. E to the ln sin x, but we leave out the c, times dy by dx. See that? Plus, oh no, e to the ln sin x again, e to the ln sin x times, what was it? Times again. Times y divided by tan x times y over tan x is equal to, and then e to the ln sin x over tan x. So equals e to the ln sin x times, what was it again? Sin x over tan x. Sin x over tan x. Okay, good. Now, let us consider this now. Sine. We have e to the ln sin x times dy by dx. So we hold e to the ln sin x and differentiate y. But the question is, what is e to the ln of sin x? Well, if you have e to the power of ln of a function, it leaves you with that function. Alright? So, therefore, what you have here is sin x times dy by dx plus, this would be sin x times y divided by tan x is equal to, this would be sin x times sin x over tan x. Alright, now let's see if we can do some simplification here. We have sin x dy by dx plus sine x times y divided by, what is tan x? It is sine x divided by cos x. So y divided by sine x over cos x is the same as y times cos x over sine x. See that? And this is equal to, now what we have here is sine x times sine x divided by tan x is sine x over cos x. So this is the same thing as sine x times cos x divided by sine x. So what we're going to have this time, cos x over sine x. Now notice what happened here. Sine x will cancel sine x. And then this sine x will also cancel sine x. So that, what do we have now? Sine x times dy by dx plus y times cos x is equal to, this would be sine x cos x. So we have sine x cos x. Alright? Now, here, look at this. This sine, you hold sine x as it is and keep it. You differentiate y plus, you hold y as it is, keep it there. When you differentiate sine, you get cos. So this is the result of using differentiation of a product. Is the product rule. So the product that you have here is y times sine x, right? And you find the derivative of this with respect to x equals sine x cos x, right? So you have sine x cos x. All right. Now, let's integrate both sides. Integrate this with respect to x. What you have here is y sine x is equal to the integral of sine x cos x. Dx. Now, we've run out of scrolling space, so let's draw a line to partition the board and continue over this side. So let's see now. We draw our line. Alright, so what we have is y sine x equals the integral of, so we have y sine x equals the integral of what again? Sine x cos x dx. So it's the integral of sine x cos x dx. What's the integral of sine x cos x dx? Well, we find ourselves again using substitution. Let u be equal to sine x. So du by dx is equal to, when you differentiate sine, you get cos x. So dx would be equal to the u over cos x. So what you have then, the integral of sine x cos x, the integral of sine x cos x dx is equal to, we're substituting now, using the substitution, the integral of u is sine x, integral of u times cos x dx. But what is dx? Dx is equal to du over cos x. Now cos x cancel cos x. So what we have is the integral of u du. What is the integral of u du? It is u squared over 2 plus c. Alright? Now, u squared over 2. What was u again? U is sine x. So what we have is sine squared x divided by 2 plus c. Alright? So here, y sine x is equal to, so y sine x is equal to, it is equal to the integral of sine x dx, the integral of sine x cos x dx. But what happened? We did that. We differentiated sine x cos x dx, and we get sine squared x over 2 plus c. So it is equal to sine squared x divided by 2 plus c. Now suppose we divide by sine x, what would we get? Y is equal to sine squared x over sine x over 2 sine x plus c over sine x. And guess what? Sine x into sine x one time, sine x into sine squared x goes sine x. So y is equal to half sine x plus c divided by sine x. Okay, so that's all it boils down to. That is what it has come to. Y equal half sine x plus c over sine x. It looks quite simple and straightforward after going through so much work to get this. Alright? So that's what we have there. Any questions, comments, and so on? You put it in the comment section. Remember to share the video with a friend. Alright, so I'll see you in the next video.